In this video, I'm going to talk about measures of position, particularly percentiles. So what is a percentile? Percentiles are used in statistics to indicate a value below which a certain percentage of the data values fall. For example, let's say you score in the 60th percentile on a standardized test. What does that mean? Well, if this was you and your score, it means that 60% of people scored below or lower than you. Now, we don't know how much lower. They could have just scored, a little bit below you and done very well. We don't know what those scores are, but we know that 60% of people had a lower score than you, and we know that 40% of people scored higher. And it's also important to note that you can never be in the 100th percentile, because if you were in the 100th percentile, it would mean that 100% of scores would be below yours. But in all of the scores, you are included, so it's impossible for you to be above yourself. So that would not be possible. It is possible, however, to be in like the 99th percentile. Say out of 100 people, 99 scored below you. You were, the top score. You could be in the 99th percentile. It's also important to mention that with percentiles, we don't know the actual value. I mentioned the value of the test. We don't know the actual value of that score. We just know where it stacks up compared to all of the other values. And so say, for instance, somebody is in the 60th percentile on a standardized test, they could have done very well. They could have gotten a 99% on the test. It just means that, 60% of people scored lower than they did, and maybe the 40% that were higher, maybe they all got 100%. So it doesn't mean that the person got 60% on the test. It just means that 60% of people scored less than they did. Okay, so how do we find a percentile? So we've got this formula here, and a percentile, or we can also say percentile rank, like I mentioned before, it's the percent of data values in a set that are below that particular value. So we can use this formula here, which just says we take the percentile rank, whatever that is equal to the number of values below X divided by N. N is the total number of values, and we multiply it by 100 to get a percent. And then the other thing I wanted to mention, we're also going to round, because oftentimes when we use this formula, we get a decimal with infinitely many decimal places. So we round to the nearest whole number if rounding is necessary. So let's jump into example 1. So in example 1, A, what percentage of the values in a data set lie at or below the 30th percentile? So remember, when we're given the percentile, that number describes the number or percent of values below. So if it says 30th percentile, that means 30% are below. What percent of values in a data set lie at or above the 30th percentile? Well, if 30% are below that value, then that means 70% are going to be above. And so just to draw the picture again, if this is the value that's at the 30th percentile, then we have 30% below, and then there's 60% or 70% rather, are going to be above. Okay, C. So if we have 500 measurements were taken, approximately how many would be at or below the 30th percentile? So we know if it's at 30th percentile, 30% are going to be below, but we want to know how many values is that. So basically what we need to do is we need to find 30% of 500. And to do that, we take the decimal equivalent of 30%. So that would be 0.30. We move that decimal 2 spots left, and then we multiply that by 500. And if we multiply those two numbers, we get 150. So 150 values would be, or actually we could say measurements, would be at or below the 30th percentile. And then for D, if 500 measurements were taken, approximately how many would be at or above the 30th percentile? So we could do one of two things here. We could take 70% of 500, since we know 70% are going to be above the 30th percentile, and we could do that by doing 0.70 times 500. The other thing we could think about is we could look at the answer to the last question. So we know 150 150 values are below, and if 150 values are below out of 500, well, 350 must be at or above. And so the answer to this question is going to be 350. So we can think about it, reason through it based on our last answer, or we can multiply 0.70 times 500. Okay, so let's jump into example 2. So in this example, suppose you have 71, or you score 71 on a test in a class of 10 people with the 11 scores listed below. So 10 other people and then yourself would make 11. What was your percentile rank? So the first thing we need to do is put the scores in order. So I already did that here. So I took these scores and I put them in order. And then I can rely on that formula I just spoke about. So we find, and the formula says if you want the percentile rank, we're going to find the number of values below 71, because we're trying to find the percentile rank of 71, divided by the total number of values. So in this case, it's 11, and then we're going to multiply by 100. And so I'm going to find 71 in the list. So 71 is right here, and it looks like we have 2 values below. So in my formula, I'm just going to write 2 divided by 11 times 100. And I'll just use my calculator here. So 2 divided by 11 times 100. And we've got 18.18 repeating. And so we round to the nearest whole number. So the nearest whole number would be 18. So we're going to say this is about the 18th percentile. Now let's take a look at example 3. This example is a little bit different because in this example we're going to consider these heights. Let's say we have a sample of 8 females, and then we're asked to find the height that roughly corresponds to the 38th percentile. So here we're given the percentile and we need to find the value that's at that percentile. So a different type of question compared to example 2. And so how do we approach this? Well, the first thing we're going to do is we're going to put the list of values in order, which I did here, and then we're going to find 38% of the total number of data values. So we're going to take 38%, which is 0.38, and we're going to multiply that by the total number of values, which is 8. So we take the percentile as a decimal times n, which is the total number of data values. And so when we do that, let me go ahead and bring up my calculator. So 0.38 times 8, we get approximately 3. Now here I would just round to the nearest whole number. You're not always going to get a whole number answer. 3.04 is very close to 3. So we'll say approximately 3. And that means 3 values are below the 38th percentile. So to find the percentile, you can think of it as, well, look at the 4th value in the list, which is 64. You could also think of it as what value has 3 below? Well, it's the number 64. And so 64 inches is in the 38th percentile. So that means the female that was 64 inches tall is taller than 38% of the other people. So now for our last example. An admissions committee is comparing 2 students who are otherwise equally capable apart from their class ranks in high school. Amanda ranked 2nd, but she was in a small high school with a graduating class of 45 people. Daniela ranked 50th, but her graduating class was much larger at 650 students. Which student has the higher percentile rank? So this is the type of situation where it's really nice to look at percentiles because, as you can see, just looking at their rank, 2nd and 50th, you can't exactly necessarily, say that the person who ranked 2nd is a better student because there were far less students in her graduating class. So what we're going to do is we're going to look at both percentiles side by side. So let's first start with Amanda and find her percentile. So remember from the formula, we're going to take the number of values below, or the number of students below her, and divide by the total number of students. And so if she scored 2nd out of 45 people, then there are going to be 45 minus 2, or 43 people below her, and we're going to divide that by the number of people in the class, which is 45. So I'm going to take my calculator and I'm going to do 43 divided by 45, and then I also want to multiply that by 100. not 1,000. There we go. Okay, so we're at 95.5. It looks like repeating. So we're going to round to the nearest whole number, which would actually be 96. So it looks like Amanda is in the 96th percentile. So I'll go ahead and write that down. And I'm going to put a times 100 here. So that looks complete. So she's in the 96th percentile. So she scored higher than 96% of other students in her class. Now let's look at Daniela. So for Daniela, we're going to do the same thing. We're going to find the number of people below her. So if there were 650 students at her school and she scored 50th, then that means 600 students are going to be below her. And in her school, there were 650 students, so that's going to go in the denominator. So I'm going to take my calculator, and I'm just going to do 600 divided by 650, and then I'm going to multiply by 100. And I get 92.3 and some change there. If I round to the nearest whole number, that would be 92. So it looks like Daniela is the 92nd percentile. So both of these people did great, but looking at the percentiles, it looked like Amanda ranked higher than Daniela since she has a higher percentile. She scored better than a larger percentage of students compared to Daniela.